Okay, before I start, everyone had gotten forms, and then I tried to collect all the questions which you guys posted. I got around 40 questions. Quite obviously, I can't cover everything, but majority are these points. So today I'll try to cover most of this. I can't cover everything in depth, but I will try to give you guys a basic introduction of the pipeline which I follow. I'll show you a lot of code. Yeah, I am. I will be recording the video. I'll try to post it on YouTube as well. Um, I will try to show you guys all the some of the projects which I've done, and hopefully you will try to get an idea of the whole pipeline, which someone who's been doing deep learning for a while will follow. Um, Many of you here are beginners. You've probably not heard of these things before, so that's cool. As a very wise person once said, if you don't understand it, that's okay. Just try to see what I'm doing. Try to understand basically the intuition behind concepts. So the next time, even if you're trying to look at it online, you'll be able to understand it better. I will first start off with an introduction to deep learning and machine learning in general. For those of you who don't know anything about machine learning yet, I will talk about the frameworks which you can use. Frameworks are the libraries, majority packages, everything which you can use. Um, I will also show you a lot of examples of code. I will show you examples of stuff which I've done and stuff which big companies, other organizations, maybe some startups are also working on. Many people have requested for like an example of how to go through a paper and implement stuff. So I've picked up one paper which I feel I can show and explain maybe how I go about it when I'm looking at it for the first time. Apart from that, I will focus more on computer vision. um, I will be explaining everything. I'm just giving you guys an overview of what you will learn by the end of this. And if time permits, I will try to talk about other technical aspects. So something like GNNs, that's graph neural networks, or recurrent neural networks, something like that. That would be a little hard to understand for people who've not had much experience with this. So I will try to do that towards the end of the video. Again, if I can't cover these things, I will just get back to me. You have my email now. Drop me an email and maybe I can explain stuff later. Okay. Um, in Before I actually start off, do any of you have any questions about the content so far? And then I'll maybe wait for a minute or two and then I'll start with my. Just put it on the chat and make sure you put it for everyone so people can see the context of the question. Um, I'm recording this video, and before that, can you guys see my screen? Just want to check if you can see my screen. Okay, cool. So this is what we will try to cover today. I'm just going to admit people. Okay, let's start with the content. The first thing is what is what is deep learning? Um, okay, I have one question. Yeah, you can actually do stuff in deep learning without knowing much of machine learning. But the point is that personally, I feel that it's better to have a better base in machine learning. Many of the concepts are related. Many of the data processing pipelines are essential for deep learning. Of course, there are many people who do say that you don't need to know both. But personally, with my experience, I found out that it's easier to walk into deep learning if you have some idea of how you handle data, how you load data, maybe about training, testing, all that. But it's fine if you depends on how much time you have and how much you are willing to invest your time on deep learning. Again, it might sound scary at first, but it's fine. It can be managed. Okay, let's start. Okay, so firstly, what's deep learning and machine learning also to an extent? In very simple terms, what all we're trying to do is we take data and we try to augment something. We try to get some value out of it. So for example, here I have one notebook, one piece of code. And what I've tried to do is, if you see these are pictures of leaves with some sort of disease to them. And maybe if someone like me who has no experience with all this looks at it, it would make no sense. Like I would have no way of saying if this is an apple scab or anything else for that matter. So what I've tried to do is I've tried to make a deep learning algorithm which allows me to identify these diseases. There's around 25 types of diseases which I'm trying to identify, because obviously it's not possible for me as a layman to identify this. And surprisingly, actually not surprisingly, but if you think about it, just in 3 iterations, I've gotten 99% accuracy, 99.4% accuracy. So for most of you who have not done deep learning before or who have done machine learning, this sounds pretty impossible, right? You might think that how he's probably just giving a value and it's not validated. But the thing is, here are the outputs, here are the predictions. So the first one is the original and the second one is the predicted. If you see, almost all of them match up. I think all of them match up here. How I've done this in just 3 iterations, I will tell you later. But that's the thing. You don't need to know every architecture. Just like normal coding, you don't really need to memorize anything. Actually, it's good if you don't memorize anything, because if you do, you will be restricting yourself, I feel. So just this was just an example of deep learning per se. You don't try to memorize anything, even whatever I tell you today. Don't try to memorize it, because it's honestly not worth it, and you will get confused, and I'm sorry about that, you will get confused later. So no, I will try to give you an overview of many of the major work in deep learning over the past few years. So the point is, just have a look, understand, maybe try to identify which domain you find more interesting. Again, if you don't understand anything right now, it's fine. I will send you all the code which I'm showing you and all the documents and links and everything which I show you. Okay, so many people have asked me how to get started. So very simply, you can start with doing courses. Very cliche, but it's actually a good way to start. Maybe after a while you might not find them interesting, but initially when you start off, even I have done a few of these courses. Some of my personal favorites are this course, which I think everyone's heard of, the great Andrew Ng course. It's called deeplearning.ai, and it's honestly one of the best courses. It's there on Coursera and it's there on YouTube as well, for those of you who don't want to go to Coursera. Um, Apart from that, I also enjoyed these courses. So for those of you who have not done machine learning yet, you can also check out these courses. Uh, Again, I'll be sending you all the links later. But I've personally not done the Udemy courses so far, but I've heard they're good and they've gotten pretty great ratings, even if you just look at it from here. So if you're just starting out, you can start with this and then maybe move on to just doing your own projects. Okay, if you guys have any questions along the thing, just keep putting it on the chat and post it to everyone. So I will try to answer them as I go along. Okay, after that, best practices I will come back to later. But according to me, this is the most interesting part of it. How do you make your own projects? How do you take real world examples and then put them into code? I will try to keep the webinar for around an hour, maybe a little less. And if there are more questions, then I might extend it. But for now, I've planned it for around an hour, a little less than an hour, actually. Okay. I find this the most interesting part of it, the whole coding, the whole point where I make something which I didn't think was possible for me to make. And the sad part is, if you look at many tutorials online, it's really scary. If even if you look at this particular thing which I wanted to show, if you look at just this example which I've shown you, where I've gotten 99.9% accuracy, it's using an architecture. This is the name of the architecture. Again, you don't need to remember this right now. But the point is, I'll show you how this architecture looks if you look at the paper. So this is how the architecture looks if you look at the paper. They've not shown the whole thing, or even if you look at it online, this is how it looks. And yeah, honestly, the first time I saw this, I decided to, just close my computer and give up. And for a very large, for around 15-20 minutes, I was almost considering going to web development. For those of you here who do know me, you know how much I am averse to web dev. But yeah, it looks scary. Honestly, it looks scary. So first time you look at it, you'll probably just freak out, but it's fine. By the end of this webinar, you will be able to realize that it's really not that scary. Maybe it is a little, but not as much as you probably thought it would be. Um, yeah, there are many sites which you can practice stuff. I will show you them. I have listed a few of them down as well. Um, there is nothing actually called beginner level. Beginner level is a misnomer, according to me. You can take the same project. You can take, even if you take this one example which I have here, if you take the Leaf project, you can look at it and you can do it properly. You can do it at a level where you get around, say, 30% accuracy or something. Or you could do it to where you get 99.4 or 97 something. Again, if you look at these websites, which I will show you, many of you have probably heard of something called Kaggle. So this is how you get the data sets. So if you look here, you can go to some of the basic data sets here. So this is my feed, but if you look at Compete, you can find some of the basic data sets where you can practice. There are, initially, don't try the competitions which are going on. Maybe try the completed ones. So maybe even try the beginner ones. Um, it's awesome for practicing. Again, 100% accuracy, no, it's not. I don't think you can even get 100% accuracy. Yeah, if you are getting 100% accuracy, there's probably something wrong, uh, because that's like saying the probability of you getting it is 1, and we all know that doesn't actually happen. I wish it did, but it doesn't happen. What happens in some frameworks is that sometimes you might see that this accuracy is 1. That's probably because you have, as someone in the comments is saying, it's a very small data set. So when you calculate the value, you get too many zeros. So you might get 99, I mean 0.99999, and then that just gets rounded off to 1. That's again not 100% accuracy, but the framework considers it like that. And then you're probably not getting that. That's not the actual value. And if you take the same model and try it out somewhere else, it's not going to work. You're not going to get very great results. Okay, so for beginners, you should have a look at Kaggle. But again, there's so many challenges, there's so many things you can look at. It gets very confusing. So initially, what I used to do is that I used to search for websites which have interesting stuff. So if I look at it, I feel like, okay, I have the motivation to continue it. Yeah, you can modify neural networks to improve accuracy by a very great extent. But that comes later. Before you modify it, you should first understand how it is, or what are the basic building blocks from it. And only then you can add stuff or make it better. I will show you a few examples as we go along, and I will show you how I've taken one model and then maybe improved it a bit for the same task, or maybe for different tasks. Um, okay, so the second thing which I would like to show you guys, is that sometimes when you just look at Kaggle or when you just look at papers, it gets very confusing and you honestly don't feel like doing anything. It's happened to me, it happens to me a lot. So, what I try to do is that I try to look at interesting examples. So, one of my favorite uh, websites is this. It's called experimentswithgoogle.com. I have shown it to many people. I It's not very popular, so not many people know about it. Okay, my internet connection slow. So what these guys have done is that they have collected many experiments from people, very creative experiments, and if you look at them, you can see the variety of things which are possible just by using deep learning or neural networks or something. So for example, some of my personal favorites are this one. It's called Semiconductor, and you can uh, basically have your own orchestra just by moving your hand up or down. It's really cool. I'll put this up if you guys want. You can test it out and have a look. It's really fun to do. There's others which I also like. This one is again one of my favorites, shadow art. So what it does is that you show it one of these shadow things, and it'll try to make it into a puppet by using a neural network. There's others like Move Mirror. This is my personal favorite. So you dance or you just move your hands around, and it'll go and find out people who have done the same move over a period of time. They have around 80,000 images, I think, and then it'll try to imitate you. So the same move you're doing, you will be given a video where someone else is doing that move as well throughout all the moves you're doing. Again, it's really fun. So I would encourage anyone to go and have a look. You can test it out, you can play with it, and then they also have a link where you can see the code. Honestly, probably not a very great idea to look at it right now because it's very complicated when you are starting off. Eventually, when you have done a few projects, maybe then it's a fun thing to look at the code and see how much you understand from it. Um, Apart from that, I would advise you to go to this another website. It's called I'm sorry, it's called Papers with Code. Um, this I feel is an amazing resource. So all, yeah, I'm pretty sure it would seem overwhelming. There's a lot of things to do, but here's the thing. If you look at it, all of these are part of some blocks. So for example, if you see all of these things like computer vision, maybe NLP, even the later technical aspects, they are all composed of the same building blocks. So let me show you an example. I had shown you this model. So for the leaf code, this is the model. I just generated it a while back. If you look at it, it's very complicated. It looks confusing, and the first time you see it, even if you see it after a year or something, it's still confusing. But if you look at it while I scroll, they're composed of the same blocks. So if you see, you'll find these words repeating. You'll find the words conv, you'll find batch normalization, ReLU, you'll find the word add repeating. And um, all of these things repeat throughout the network. So if you see this one block here has been repeated again, has been repeated again, has been repeated again. So if you look at it, all of these things stem or they start off with the same blocks. And once you learn the blocks, then you can look at a paper and say, okay, fine, this is possible for me. I will show you an example later. I will show you how you can do that. I will go there. But I figured it's better to give you guys a little more background before we go there. Um, Python knowledge is compulsory, yeah, and Python is honestly one of the easiest languages, which is why it's there. But there are many other ways of doing it. There's other languages like Julia. You can even do it with JavaScript if you know JavaScript. But personally, I find Python to be the most user-friendly language, and it's just easy to learn. So if you see this whole thing, this whole architecture, which just goes on forever, is literally just one line. It's literally just this much. This line, this implements this whole thing. Of course, this doesn't work for every model. This is one of the pre-trained pre-given models from this library. But yeah, Python is much easier to do this. Now, for those of you who have worked with other languages, can you imagine writing something like this in C++ or even C for that matter? Like, no, I would rather not. I don't even want to think about it. It's scary. It's very scary. So I'd rather not go there. Um, okay. Another question which I've been getting a lot from people is frameworks. So there's a library called TensorFlow, which you've probably heard of more. And there's also PyTorch. You would have heard of TensorFlow more because it's by Google, and those guys are really good at advertisement. You will see TensorFlow everywhere you go. If you literally search for deep learning, you will find TensorFlow. You know what? Let's try that. Let's search for some random thing. Let's search for ImageNet, GitHub. So if you see, I find one with PyTorch, and literally the rest of it will be TensorFlow. I've been through many of these codes, and almost all of them are TensorFlow, 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 and so on. Uh, but personally, I find PyTorch easier to use. It's more Pythonic than TensorFlow. Uh, People might disagree, but what I've seen majority is that people who are more into research, they are fond of PyTorch more. But there are people who are into production. So say if you want to implement the same thing on an Arduino board, for example, then TensorFlow is probably a better bet for now. They might get there soon, but PyTorch is more user friendly, according to me. Um, another framework which is relatively new. It's not a framework per se, but it's called ONNX. It's a file format. The whole point is you can make your model in any of these libraries, and it'll be a common thing. So you can make something in PyTorch and then use it in Keras or vice versa. So basically just pick whatever you find easier to learn from. If you have no prior coding knowledge, or if you're not that great at coding, maybe look at TensorFlow because there are more examples. To be very frank, there are more examples online. If you have coded before, if you are pretty okay with coding a little bit here and there, then PyTorch is your bet. You can do it and it'll work perfectly. Um, Okay, another thing which I find the most interesting, and this is my favorite part, honestly, is how to make a real world problem, how to take any of the models you've learned so far. So any model you take is still theoretical, right? You're not doing anything with it. So one example, I won't explain this part right now because it's something called a graph neural network, and I was messing around with it yesterday. The whole point is you can use something like this to generate chemicals. I don't understand this. To be very honest, I don't know what this means, what this chemical represents. But the point is, you can use something like this to create your own chemicals based on some constraint. So you can use it for, say, drug design. And I was actually looking at one paper where they had used this for the coronavirus thing, which is going on now. I don't know how far they've managed to make it, but I guess they're trying to do a sort of drug synthesis using something like this. This is called a graph neural network, and not the time for it right now. Maybe for those of you who have a little more experience with it, you can check this thing out because it's a really cool concept. It's not very old. I think the defining paper for this is from 2018. So it's a very new thing, but it's really cool. Okay. Um, I'm pretty sure by this point you're already overwhelmed with way too much information. So let's go down to how you can take all this and how you can make it into a project. So if you want to learn deep learning, it's better to understand the flow of things. So maybe take a simple example. This is actually a simple example, or you can do a cat and dog thing, which I keep seeing everywhere. Um, what you can start off with is that first find out how to load the data. Basically, if you have pictures, so in this case, I have, um, this is just one category which I've imported, but if you see, I have a lot of these categories. So and all of these have pictures. So the first thing you should learn is how to work with the data. And maybe it's a better bet if you have done machine learning before, because you would have already have some idea with how to get the data. If not, that's totally cool. Again, I will not explain the code. If you want extra information later, you can reach out to me, but um, I will just run you through it. So in this case, my aim is to predict which disease the plant has. Okay, my browser is lagging. So there are basically very few steps to every deep learning pipeline. Every pipeline, and this is true for anything you do throughout the course of every project you will do. You have to first get the data. Um, this is a library which I've used called FastAI. You don't need to look at it right now, but personally, I find that it's a really cool thing because it handles a lot of stuff. So this line of code here is around, I think, 20, 30 lines of just plain Python code. Instead of that, you can do it in one line. So, I mean, why not? Right. I will be sending you the notebooks later. So if you don't catch anything right now, just have a look at it. And it's honestly not that hard to understand. So every pipeline starts with me loading the data. Then I define a model. Once I have the model, then I run the whole iteration of deep learning, and that's it. I get predictions. Of course, it sounds overly simple, but uh, f- contrary to every tutorial I've seen myself, it's literally that. This is all you have. There are just many ways of doing this, many variations to this, but that's it. This is literally all you need to know when you're starting out. Okay, guys, I will move on a little more, but before that, do you have any questions? I will stop for a minute or so. And if you do have any questions, just put it on the chat. Mm, I'm surprised. Everyone's understanding everything. I will show you GNNs. Uh, so this is an example of a GNN, actually. I probably shouldn't explain GNNs fully because, to be very honest, it's very complicated. I can give you an overall explanation for it, but for those of you who have not done deep learning before, it's pretty messed up, pretty complicated. Uh, okay, ONNX is basically a file format. So if you take something like a text file, you can read it in any way. You can read it in Python, you can read it in your normal text editor, you can even open it on Word. So what ONNX does is that it takes the same thing for a deep learning model. So you can take something like some model you've made here. So if I take this model, you see here I've used the ONNX format. I can take this model which I've made here and I can use it anywhere. I can use it on the browser. So I don't need to write any Python code anymore when I need to use it on the browser. I can take this directly and use it in JavaScript, which makes it so that people who don't want to learn Python, they can make the deep learning thing in any library they want, and then you can use it cross compatible with everything. Okay, how to read a research paper? Yeah, that's a pretty good question, and I thought I'll show you guys how I go about it. Again, it everything seems challenging if you don't know how to go about it or if you don't have practice. So I've taken this one paper. Um, it's a very recent paper, I think 2017 paper. It's called MobileNet and it's by Google. Okay, no, it's a little older, not 2017. So generally, when you look at it the first time, even if I just scroll through it, that's a lot of text. That's a lot of text, and it would make no sense if you just look at it once. Uh, Even the first time I decided to look at papers, it was very complicated. There was no way uh, I would listen to anyone saying, huh, you can understand this if you read it twice. Because, I mean, there's 8 pages of text. But if you look at it from a research oriented way, if you look at it from a the way of a coder, that's just much easier. So initially, how I would go about just this one paper is I would read the abstract, and once I'm done reading the abstract, I'll know what they want to talk about, and that is by far the most important thing, because without context, none of this makes sense. You could read this 30 times and you won't understand anything unless you know what they want to do. So this paper, what they have tried to do is that they've tried to make a new type of network which would be smaller. So it would be faster than a bigger or a different type of network. And generally what I do when I look at a paper is right after reading the abstract, I skip everything. I skip all of this and I look at all the pictures they have. Just like when you would read books as a kid, those pictures and stuff. But uh, it's actually a good idea because every time you look at a picture, you have a little more understanding. Like right now, if I look at this, I know that this is the sum of what they're trying to implement. So in the whole paper, all they have done is worked with this, just this bit and this bit. And the second thing I look at after the pictures are tables. Now, if you have not worked with deep learning before, this would make no sense. But if you look at it, everything I've shown you so far. So if you take this conv, you'll see conv here. A conv is convolution. If you want to see max pool, there's max pool. There's max pool. And the funny thing is, these two aren't even the same thing. This is a completely different model. This is also a completely different model. It's not even from the same year. Actually, this one is a older one, I think, to this. But all these parts are the same. Now, the second thing you would notice is this. This sounds unfamiliar. I have no idea what Inception is. And then if you look, this is what they were talking about. This is Inception. So this is the only thing they have introduced in this paper. And once I know that, sorry about that. Once I know that, then I'll be able to implement it. Uh, if you want to look at deep learning from a research point of view, which according to me translates to make projects, you have to practice. So what I do is I go to this website. It's called Papers with Code. So what these guys do is that they collect papers, and unlike you just looking at the paper, they will give you the code for it. So if you want to take this paper, which I'm showing you right now, it's called Google Net. I hope I find it in one go. Okay, maybe not. The point is you can search for any of these papers. Not all of them are part of this website, but majority of the, yeah, so this is a paper. Okay, it was a 2015 paper. So this is this paper which I was talking about. Now, if you just look at this website, you'll see that they've not only given you the paper, and then they've also given you the code. So that's awesome if you want to look at it from a research perspective. For some reason, this link is not working. Okay, I don't know, maybe it's glitching. But the point is, it does have code for almost all the top papers. So if you take any of the tasks, which also I find a good thing to do. So if you take something like computer vision, you can look at all the things which have been done in computer vision so far. So again, if you look at it, this is scary. This goes on, this goes on forever. You can keep scrolling for like 5 minutes and it'll still be going down. But if you just stop for a bit and look at it, you'll see that each of these papers build up on the same thing. Any paper you open in this whole thing. So if you keep scrolling for 5 minutes, and maybe even if you go to the end of it, even if you click something like food recognition, you will still see ReLU, you will still see batch norm, you will still see con, you will still see max code. Each of these things are there, anything you do. So if you are getting scared, I would advise you to first find out all the blocks which are required. Again, you can't do everything and you can't know everything, but once you have the basics done, once you know what each of these small things do, then you can literally pick up any paper and you can understand how it works. Uh, so from a research perspective, this website is the best. You could go and any domain you pick up from this, you can research on it. So even if I see a small thing, if I take semantic segmentation, again, for those of you who have no idea what this is, it's okay, totally cool. But my point is, there's 854 papers of people who have worked on just this one domain. Um, Personally, I feel like if you want to work more, if you want to have your own papers, don't go with stuff which has been worked on a lot. You can probably look at other stuff. So if I take something like this, it just has 19 papers. This is not the total papers out of everything, but these are 19 top papers. So uh, if you want to do research, so pick up one of these which haven't been worked on a lot and then work on them if you understand it. But again, that comes later. But the whole point is, don't get freaked out, because it's really not that hard. All you need to do is understand the basics and then build up and practice a lot of practice. Okay. Uh, Someone was asking me, if you, when you're working on a text generation model or literally anything, so any model you pick up, you might get horrible outputs. So I think this is another code. So the paper I was showing you right now, this has been implemented here. So this is the implementation for it. This part looks complicated, so I'm not going to explain this for now. But if you see, I have gotten horrible results. I have gotten 80% error. That's literally nothing. It's 19.5% accuracy, which is pretty horrible. So I keep training, and towards the end, also, I don't think I've gotten that much. I think the max accuracy I've gotten here is uh, 70% accuracy. So there are many ways of getting from 20 to 70, and there are many ways of making this 70 into around 90. This exact paper, I think you can go to around 98, 97, 98% on the task which I'm doing. So there are many ways you can improve it. Uh, that's a very technical aspect of it. So if I start explaining that, it'll go on for a very long time, and I can't actually go there. So there's one concept which someone's asked me that as well. Okay, there's a very cool concept called transfer learning. So that's the secret of how, I wouldn't call it a secret, but that's how you get 99.4 with just 3 iterations. And by the way, this thing took me just this much time. So 15 minutes per iteration, and I could cut this down. So if I run this now, it's one of the things I've done a long time back, and I didn't really know that much back then. But if I do the same thing now, it would take me, I think, 15 minutes to run the whole thing at once. And I would already have 99.4% accuracy. The question is how? How do you do this? So um, this is something called transfer learning. I will give you an annotation thing. Yeah. So what happens is, sometimes you have one trained model here. So let's just call this model A. And right now, this model has learned to identify around 100 things. So I have 100 things which my model here can identify. Uh, but you are now given something like these leaves here, which are not part of your model. So um, what do you do then? I mean, how would you use this here? So there's something called transfer learning, and I've done this here as well. So this part, this CNN learner part of it, all it does is that I can give it a pre-trained model. So someone else with more laptops, so someone like, say, Google, who has been training a model for a week, say, has uploaded the model. This is one of the models. I am not sure who's done ResNet. It's a Microsoft paper. So ResNet, this model was uploaded by Microsoft on their website. And all I can do is that I can take this, I can take just this one line of code, and then I can use their model. And all I have to do is give it my data now. So I give it this data, which I have. And then once I run it, because it's already learned to recognize 100 different things. So now when I give it this, it can learn this easier. It can learn this more easily. And then I will get 99 with just 15 minutes, or whatever time it took me here. Um, so yeah, that's how you would work out in general. Many of these problems, such as Elinet, this problem here, you don't really need to do this again. I would advise you to first use transfer learning. First, work with the model, see how you can implement transfer learning, see how you can use other people's code. Yeah, that you should learn to use other people's code. And then once you have some idea with it, then you can start implementing other stuff. You can start making your own networks, maybe writing your own papers at some point. But that comes later. That's not something which you start instantly. Okay. Uh, Competitions. So almost all the major deep learning, machine learning competitions, everything come on Kaggle. There are other websites also. There's something called Omdena as well. Yeah, this is another website which has these competitions. Um, your understanding of all these, so this thing also, this the whole data set, this is also from a competition. So this is, you can say, the solution to one of the competitions on Kaggle. Maybe I can show it to you as well. So okay, I will have to search for it, but yeah, the uh, data, I mean, yeah, this is the data set. So this was a competition on Kaggle, and all I did was that I downloaded this data set and I tried to get an accuracy on it. I tried to predict, my whole notebook is based on this challenge. So my understanding of deep learning was used for this. I didn't upload the code on this because it's already done. So no point in me doing it again on this. But I guess I did get as good as a result as the top answer for these guys. Um, okay, decision trees and random forest, that's not a part of deep learning. It's a machine learning thing. And those are just algorithms. So this is a neural network. Instead of using a neural network, I could use something like decision trees, random forest, regressions, all that. But obviously, it doesn't work that well with images, which is why we go to deep learning. But yeah, it's just another means to the same end. Okay. Um, since I have talked about a lot of things right now, neural networks and deep learning, actually, neural networks and deep learnings are not synonyms. It's a common thing to mistake because everyone refers to them to be the same thing. But deep learning basically refers to anything which uses something called a convolution. uh, I don't want to get into the technicalities, but there's many parts of deep learning which don't require neural networks. So a graph network is something else. There's 3D networks, a lot of other stuff which don't actually use the same stuff as a neural network. They're similar, but they're not the same. Um, okay. If you are already messing around with all these things, and sometimes it might be slow, sometimes you might get a performance drop. There are many ways of overcoming it. The easiest way of fixing it, the easiest way of increasing the speed of your algorithm is by changing the size of the image. Okay. Someone's drawing on the screen. That's cool. Would be nice if you stop though. Okay, so all you have to do is reduce the size of the image. So if you are working with text or anything, just reduce something called the batch size. So it's called the batch size. If you reduce it down to, uh, if you increase it up, you will get your code to run faster. And if you reduce the size, if you're working with images, just reduce the size. So instead of 224, if I had made this 32 or maybe 64, this would be done in 5 minutes or less. The whole thing would be done in 5 minutes or less. So yeah, okay. Yeah, that's the thing. Any other questions before I move on to the next bit? Reducing size and accuracy, actually, that depends on what you're trying to do. It wouldn't reduce your accuracy for some things, but the whole point is if you reduce the size, it will just uh, not work if you take it with bigger images. So, for example, if I take a size of 224 and I train my network for this, and then instead of this, if I take this as 32 and train it on this, the next time I give it a 224 image, it might not predict it properly. So sometimes this actually leads to a drop in accuracy. Sometimes it leads to an increase in accuracy, but the whole point is there's a way of doing training. You generally, what you do is if you want to make this into an even better network, you would first train it on a bigger image. You would first train it on say 224. Then you would transfer learn the model you have here, and then you would train it on a smaller image again. So you would have your model learn from bigger images as well as small images, and then you can transfer learn back and learn it for even bigger images. So um, an example of this way of doing, it's not out there a lot, so you might not find this whole way of doing things a lot around, but it's there. It's a relatively recent one. I've only heard one or two people talking about it. So you increase the size, train, reduce the size, train. You get better accuracy. It does take more time though. So maybe it's not possible if you don't have a capable system. And it's honestly not a very great idea if you're trying to do this on Colab. I mean, it might work, but I don't have that much patience at least. Okay. ONNX, there's not that much to elaborate per se, but all it does is that it allows moving between frameworks. So if I train this one model here, so if I have my classifier here, which if you give it a leaf, it'll tell you which disease it has. Now, I don't want to run it on my laptop. I want to run it on a phone, say. And generally, you would have to rewrite the library. You would have to make it again. If I want to do the same thing for a browser, a phone, and maybe I want to, and maybe my friend doesn't know PyTorch and he wants to do this in TensorFlow. So I can take this and send him the ONNX model from it, and then you can basically cross-compatible it with almost any library. So be it Keras, TensorFlow, PyTorch, JavaScript, all of that. So that's what ONNX does. Nothing much to explain really. All you do is once you're done training, you export your model to an ONNX model, and then you can use it anywhere. So even this app here, which allows me to visualize the network, runs on ONNX. So if you see the model here, I've done it in Python, but this thing, it takes it from a JavaScript version of it. And all I had to do is that take my Python model and export it to ONNX. This guy has written his part on JavaScript. So I think, I'm not sure, but this also is cross compatible with a lot of things. So it would be cross compatible with a TensorFlow model or a Keras model or anything. Okay. As for IDEs, actually, I don't use IDEs that much. This thing is a Jupyter Lab. It's the next version of Jupyter Notebook. So if you see, there are themes which you won't get for a normal Jupyter Notebook and all that. And this is a proper IDE. I mean, it has literally everything you want. Recently, they also implemented, where is it? There's one variable. Uh, so you can have formattings and everything which you would need in an IDE. And then there's also a variable viewer, so it'll show you variable inspector, whatever. I can't find it. This is literally almost everything you want. So it even has extra settings, everything. For me, this is more than enough, but sometimes sometimes these things don't work. So if I'm working with videos, Jupyter Notebook is not a very great thing. So then I use Atom. So this is Atom. You can use Sublime Text as well. Or if you want to go full on interface, then you can use Visual Studio Code um, or PyCharm. I think majority of the people use either PyCharm or Visual Studio Code. personally, I'm happy with Jupyter and Atom. It's a good combination at once. So whatever I don't want to work on Jupyter, I can do it on a normal text editor. So yeah. Okay. Another thing I think many of you had asked me about, okay, yeah, was how do you choose an algorithm? Like, how do I say that, I want to use ResNet 18? So, for example, there's all these. These are just some of them. There's, I think, hundreds and thousands of models. So maybe how do you choose? So to put it very bluntly, you can't look at the name of the model and say, you know what, I want ResNet 18 for this. But what you can do is you can get an intuition. So the first few projects you do, try to use as many of these networks as possible and see how it performs, and then try and understand why it's doing what it does. So for example, ResNet 18 here is a relatively small network. So I think I can show you that network as well. Yeah, it's okay. So it looks long, but all of these are the same thing. So this block has been repeated again and again until here. So this is actually a very small model. It has, as the name suggests, only 18 layers, which is very tiny, because if you see the others, this one has 152 and 101. And if I print one of these, it's insane. Like it goes on forever. How you would choose is that depends on your task. So these models like ResNet 152 and all this, these are used for stuff where you have ResNet 18, the one I was using before. So ResNet 18 is used for stuff where you don't have that many classes per se. So because it's a smaller network, it won't learn that much as say a bigger network such as ResNet 152. Again, you would have to try it out, and then it depends on your task. Okay, YOLO. Yeah, you could use YOLO. So YOLO is one of the relatively newer papers. It's called You Only Look Once. I mean, pun intended, probably. But it's mostly used for multiple object recognition. So this is just one leaf. So I give it a picture of one leaf and I try to detect it. But suppose I want to do something like I give it a picture of my whole plant and it'll try to identify every single leaf with diseases. There I could use YOLO. So again, you can learn all this by reading it. You don't have to understand what all these do, but if you just pick up any one task, so something like using YOLO would be um, object recognition here somewhere. And then if you look at it, you can see, so object detection here or image classification. Then if you pick up one of these, you can see all the stuff which people have used. And then you'll have a better idea of which model you need to choose. Again, it's not specific, that no one said that, if I don't want to use ResNet 152, I can't use anything else. That's not the case. There's LXNet, there's VGG16, there's a lot. And it does sound confusing, but again, if you look at the blocks, they are made up of the same thing. So this is just practice. And the more you look at this page, the more you try to see what these guys have done, the more you'll understand which one to use better. Okay, so you want to train image captioning on Coco? Okay, so sadly, if you want to train something like Coco, which for those of you who don't know, is a data set. Okay, it's called Coco, Common Objects in Context, and it's a very huge data set. So um, it has 330,000 images and 1.5 million object instances, which is 1.5 million times the images have occurred, or the objects like something like a dog or a human have occurred in the data set. And there's 80 classes. So if you want to do it on your laptop or on Colab, that's not advisable unless you're totally cool with leaving your laptop running for a week or 2 weeks. Maybe it would take you a really long time to train Coco. And plus it might crash, and then you will be sad, because If you try to do something for 2 weeks and it doesn't work, you might end up pretending it's Flappy Bird and throwing your laptop out of the window. But no, you can't train Coco on one GPU, to be more precise. If you have, say, 3 or 4 GPUs, you could probably still do a distributed training. But I mean, why would you, to be honest? Coco has already been trained, and you can download the pre-trained models even from the website. So if you see the tasks here, each of these guys have pre-trained models which you can download and use. So you don't really need to train it again, but you can take the pre-trained model like I've done here and then use it for your case. Okay, I have a long question. Okay, so if you want to train custom libraries, um, the default layers would be hard to modify, would be hard to implement directly. But here's the thing, and this is not for the people who are just starting out. There's no need for you to do it. You don't need to think about it. But if you have been working with it for a while, and if you want to change your own layers, you want to make your own code, there's something in Python called inheritance. For any coder out there, if you've done object-oriented programming, there's something called inheritance. So what inheritance does is that basically you take a library from PyTorch or TensorFlow or anything, but instead of rewriting it from scratch, you just change small bits of it. So for example, I take the CNN learner class here. And this is a really cool trick in Python, which I don't think a lot of people know. But if you want help or documentation for any code, proper documentation, you can put the name of the code, name of the object, so CNN learner here, say, and I can put 2 question marks, and I will get the whole documentation. I will also get an example. So this is the source. Sometimes there are no examples, but this is pretty much it. So this tells you everything you need here. But the thing is, if you see this particular function, if I take the definition of this, if you want to modify this, if you want to add your own stuff, all you have to do is inherit the class. So you make your own class with the same name, and then you take this class and you just add your own features to it. So yeah, it is possible to do. Okay, if I have to explain Inception modules, it's a little complicated to explain. So for the rest of you who don't get it fully, that's fine. Just see how things fit in. So I can take a model here. So I can take, say, the ResNet 152 model. And then all Inception does is, I will show you an example. So this paper has implemented Inception. So this is an Inception module. This is also an Inception module. So all I do with the Inception class is that I take one layer. So this is one of the hidden layers in your neural network. Um, so I take one of this and then I split it into multiple convolutions. So if you see all the stuff which I've done so far, as an example, if you take the first part is just going into another part. But instead of that, I split it into multiple parts and I try to um, basically do the convolutions on them and then pool them together. And basically there's something called a filter concatenation where I take all the outputs and instead of taking them separately, I concatenate them and come, like, instead of adding them up, which you would do, I concatenate them. So I take them in one module. So as an example, I guess, so for those of you who don't get it, just have a look at this once, see if you can understand a little bit. So when you reach this part, when you are even looking at it, it's just easier to understand. So suppose I have one block here, which is this part, the previous layer. All I do is I split it into multiple bits. Okay, that's a very horrible diagram. Uh, I split it into multiple bits and then I apply convolutions to each of this. So this is your convolution. I apply it to all of them, and then this will give me an output, this will give me an output, this will give me an output. And all I do is that I make it into an array or a list, and then I place them side by side. So this, and so on. So all of these are these outputs here. So this is what Inception does basically. Um, it makes it a very deep network, and it makes it a hard to train network, but you get very, very great accuracy. It was one of the top papers for one data set which had 1,000 classes, which is really cool. If you think about it. Okay. As for internships or deep learning based jobs, that sort of depends on where you're doing it. So it mostly depends on the project. So there are some people who might ask you to work on specific tasks. So one of the internships I had done, I was asked to make a traffic recognizer sort of thing, vehicle detection slash traffic recognizer. I had to identify if the vehicles on the road were overspeeding or going in the wrong direction or something like that. That was one. Other places, I was asked to um, use natural language processing. I had to make one algorithm which would identify legal terms in a phrase or a sentence, maybe segregate them from the rest of it. Again, that depends very specifically on the domain you choose, um, which is why I think I had divided my talk into bits. So there's computer vision, and then there's also uh, natural language processing and other domains. So the work you get mostly depends on which domain this company works on. So some of the examples are autonomous driving, there's face recognition, there's healthcare, image generation. All these are some stuff you might get in your internship. But that depends. If you go to a company which wants to make a chatbot, then you won't get these, you will get something else. But it's not overwhelming if you think about the fact that even if you have to make a chatbot, it still uses the same blocks as computer vision. Not all the same blocks, but a majority of them are the same stuff. Okay. If you have just done theoretical courses, just like the ones even I showed you initially, uh, if you even want to start doing it practically, it's going to be a hassle. You will struggle and it will be really scary. But how I would suggest is that you look at blogs. You look at blogs on how people have done. So, as an example, again, don't try to understand this right now, but just as an example, I was trying to search for some blogs in the morning today for one task I had. And this is a forum of Fast AI. And all they've done is that anyone who's had doubts before on the same topics has put it up here. It's a really cool forum. You can ask questions on deep learning, or uh, it's not for machine learning per se, but for deep learning, everything. You should go to Kaggle and mostly just look at the kernels initially. So kernel is basically someone else who's put up the code. So for example, I take this AlexNet and I try to see what this person has done. So this is something called AlexNet. It's one more library. It's one more what do you call architecture, and it will not give very great results as far as I know. But anyway, the if I look at this code, I will be able to solve this challenge to an extent. And initially, once you start and you do a few of these codes, you can try to use other stuff you've learned, maybe from research papers or something like that. So that's how you go about doing projects. And I would advise anyone who wants to start off to first do courses. And while you're doing that, you look at Kaggle, you look at Omdana, or even papers with code. But this is probably for a little later. Um, you can for colleges internships, okay, you can apply online. There's If you look at LinkedIn, there's a lot of people who want internships for this. But personally, I find if it's the first time you're doing something, maybe look for startups because they're easier to get into, and more importantly, you will learn more there. So because in a big company you have a defined role. So once you start that, since you have a defined role, they will just give you one task and you will be doing that. But for other startups and stuff, they will ask you to do a variety of things, which means that you will learn more, basically. Okay, I will take more questions a little later. I will continue with the rest of what I decided to show you. Okay, another extremely interesting thing is computer vision. And this is the last bit of what I'll show. For people who want to know about graph neural networks or natural language processing, you can text me later personally or just drop me an email or something. Um, I will show you one project which I really liked. Um, and I think that's one of the stuff which has started me on my interest in deep learning. So it's this one link. It's a self-driving car, and it's really cool. This is a really cool website. I again don't want to explain it, but I just want to show you that if the more you look at these, the more you look at the work people have been doing, it gets more interesting. So this guy is a professor from MIT. He, and this is one of like his website where he's put up talks and lectures and stuff. And if you look at a few of them, you'll see how much work goes into each of these. And it's honestly interesting and it's fun. So just basically look at projects, look at as many projects as you can. I have made a list of few of them. I won't be showing you all of them because it's been a solid while. I will share this with everyone who is here. So that's it. You can have a look at it. I would suggest that you look at all the links which I sent. Choose, see what you like, and then maybe go with it. Okay. One last question for now. Um, Papers with code, as and just as a continuation to what I've been talking about so far, for every project, papers with code isn't the best thing to go to because it's just a compilation. Yeah, it's a compilation of all the topics. So everything I've shown till now. So this particular model, ResNet 18, this is the LENet model, the ResNet 18 model. You will find it here. You will find it on papers with code. But if you look at this, it'll make no sense. You can keep scrolling for half your life and you're not going to understand anything. So go to papers with code only when you need inspiration or when you want the code for a specific model you're looking for or a specific task you're looking for. Okay, I would like to sort of end this talk, but before I stop it, I want to talk about one thing, and that is bias in AI, and it's not a very talked about thing, and it relates to production or when you're working with data scientists or for data analysis later. It's something you need to consider, and it's not a very huge thing to learn as of now, but just think about the fact that every time you make a model, every time you make something, you have to see the audience. So for something like plants, to someone here who's just making a model to recognize the types of diseases, it might not be that much of a big deal if you say have something where instead of apple scab it shows me some other disease, because to you, you're just coding it. It's really not that huge of a deal because you know that you can't get that much accuracy, you can't get 100%. But you have to consider what happens when your model doesn't work, or you have to consider who your model affects. So if I have something like face recognition, it should not be biased towards people of color. And it's happened before, and people have gotten, and companies have gotten sued for it. I think Google had to pay a few billion. I think so. I'm not fully sure how much they paid, but it was a really huge legal case. So the point is, maybe you might think that, I'm just starting off now. What am I going to do with this information? The point is, every time you make a model now or in the future, it's a good thing to consider who it's for and collect the data or look at the data accordingly. So these are just theoretical things. These are maybe not that used right now. But say I take something like a graph neural network and it gives me this compound. Now, if it's just me and all I'm doing is generating this, it makes no difference to me what it looks like, because I'm just creating new things, right? But for someone who uses it, they should know how I got this. They should know where this came from, and that's very important. So keep that in mind. You don't need to specifically learn how to do it right now, but just keep it in mind. So every time you make something, try to think about who it would affect, and it would help you a lot to understand the use case and understand how it works out later in the future. Okay, guys, thank you. I will wrap up now. For the other stuff, which I didn't have the time to explain, it's actually information overload. So maybe approach me later. Yeah, thank you. If you guys have any questions, you can stick around. If not, that's awesome. Feel free to send me an email on your doubts or anything else you want to talk about. I'll hang around for a little more and try to answer everyone else's doubts. But as of now, I'm done with my topic, and I will be sending you all the codes and everything. You're welcome, guys. Thank you. It's great that you enjoyed it. Okay, I'll try to answer all the questions which I haven't been able to so far. Um, if the rest of you want to hang around, feel free to. Maybe you might learn something new. Um, but if you feel like it's going over your head now, it's okay. Uh, this is not everything which you should know in one go. Thanks a lot, guys. It's awesome to know you've enjoyed it. Okay, reinforcement learning is, yeah, I will try to upload the recording of this on YouTube. Um, you're welcome. It's again awesome that you've enjoyed it. Okay, as for the doubts, okay, the first thing is resources for reinforcement learning. So the best resource I have encountered for reinforcement learning is OpenAI Gym. Um, it's beautiful, and these guys have basically collected all kinds of problems for reinforcement learning, and the best part is their documentations are tutorials, and it's really cool. So you can pick up any environment and they have taught you everything about how to use it and all that. They also have uh, blogs from them, which is really cool. So if you want to learn reinforcement learning, you can do this, or there are a few courses on Coursera. Uh, Actually, the Udacity course is good. So that's it. I will try and send you the links. Okay. Another question which I had was information on computer vision. Okay, so computer vision is a very, very broad topic, and you can learn it from the courses to an extent. So if you look at any of the courses which I had mentioned here, so maybe A to Z or deeplearning.ai or even the fast AI course, you can learn it from there. But again, you can't learn everything. It's just an introduction. So once you do any of these courses, you will be able to pick up papers, or you'll be able to pick up maybe other code on the internet and try and understand computer vision. But it'll take time and patience. So thank you everyone for attending. It was really cool. Love the fact that you guys enjoyed it as well. Okay. Yeah. If you want to try any projects where you want to web scrape the data, yeah, sure. I have an example. Okay, if I look, it'll take me forever to find it. But what you can do is that you can um, web scrape text data. Yeah, I will send the link on computer vision. No issues on that. Okay, if you want to web scrape stuff, you can try with text data. So one of the stuff which I had done, again, if I try looking for it now, it's going to take me forever to find it. But what you can do is you can go to any website. So even if you go to something like Wikipedia, you can extract text from certain pages which you are interested in and try to do an analysis on that. Maybe predict topics from it. And all this is web scraping. Another very common project is sentiment analysis from Twitter. I am personally bored of seeing it everywhere, but it's a good thing to start off with. So all you have to do is you have to scrape data from Twitter and then do data analysis on that. Okay. The next question I have is, okay, no, the bias I was talking about is not the same bias for deep learning. So there are parameters, hyperparameters in the neural networks which are related to bias. That's not the same thing. I was talking more of a production oriented consequence to your model. The bias for a neural network itself is a hyperparameter. So it's something which uh, basically defines how much your model places weightage to certain things in the network. Yeah, a lot of links. People have asked me too many questions, so a lot of links. Okay. Um, Transfer learning is actually an extremely important and really cool thing. And it works because if you think about it very simply, if you as a person know what a vehicle is, if someone gives you a vehicle you have never seen before, you might not be able to. So, for example, if all you have seen in your life are, I don't know, Toyotas or Mercedes or whatever, off the top of my head. And if someone shows you a Ferrari, you might not be able to say that, huh, this is a Ferrari, but you will be able to say that it's a car. And that's how it works. That's how the principle of transfer learning works. You you take a model which has already learned 1,000 things, and then the next time it looks at anything, because it already has an idea of the world, it can learn faster. If you want to learn TensorFlow too in depth, honestly, just look at any course. So the deeplearning.ai course is on TensorFlow completely. If you want to, mostly just look at the documentation. So if you look at the TensorFlow documentation, uh, they have given all examples. They have given examples for every language. They have given tutorials for everything. That's honestly all you need. It might look confusing at first, but there are tutorials. So you can just look at the learn ML thing and you'll be done, sort of. Yeah, initial layers might be the same. Actually, sometimes you don't just tweak the last few layers, but you take the model and unfreeze all the layers, or you can just unfreeze the last few layers and train. I mean, that's up to you. Again, if you already have a pre-trained network, it makes no sense to unfreeze everything and start working from scratch. That sort of defeats the point. But if you have enough resources, then why not? Okay. There is nothing called a proper project. Yeah, it depends on the train test data. That's it. There's nothing called a proper project per se. You see, initially when you're starting off, you need to learn, and while you're learning, you can pick up small examples, small projects. Later, I would suggest my definition of a proper project is anything which adds some value. So, as an example, I will show you one project I was working on a few days back. Okay, so it's something called a dehazer, and what it's done is that you give it a hazy image, such as this one here, and then it'll try to extract the original content from it. So I take this, and then it'll give me this. Which honestly, if I look at this picture or this picture, the last one especially, I have no idea what this is. Maybe if I zoom in and stare at it for a bit, I will be able to understand what it is. But uh, something like this is something a neural network would be great at. So to me, this is a good project because it does something. But initially, when you're learning, it's really not that important. Um, okay, a product is basically just a model in deployment. So once you have made this model, all you do is you export the model, and then maybe you can try to integrate it with a web API kind of thing. So maybe you can integrate it with TensorFlow JS or serve it as a website. So that would be later stage of your project, and then that will be a product. If you host it on your own website, you can sell it as a service if it's actually worth that. um, deeplearning.ai course, no, actually, deeplearning.ai is the theoretical version of it mostly. So if you've done the theoretical version of the course, their TensorFlow course is also cool. But then again, if you already have the basics of deep learning done, you don't need to specifically do a course on TensorFlow or PyTorch for that matter. Just look at some of the tutorials, for stuff you've done, and then you learn how to use it eventually. You don't need to do a course for every language or every library. It's a waste of time, according to me. People do suggest that you keep doing courses, but I mean, not my way of learning. I would still go about doing courses, but I learn better from code. So if someone shows me the code and explains a bit of it, it's easier for me to understand. Um, okay, I will hang around for a little more. If you guys have any more questions, just feel free to ask. And for those of you who have not gotten your answers from my content, please ask me now because I can explain with a little more time right now. So something like if you want to learn any more about some of the advanced topics, then I can cover it right now. Okay. Yeah. Will a data scientist or data analyst be working with deep learning? Again, depends. Mostly deep learning doesn't work that well for tabular data so far, except, and it's a case of something called a recurrent neural network. So the whole point is if you have something like a time series, or as an example, if you want to do something like stock prediction, then it's a good idea. So you can use something like an RNN or an LSTM for some work like that. Again, that depends on your task. Mostly you wouldn't need it as a data scientist, but because if you're just analyzing the data, you don't need to specifically make a model. But if you're requested to, yeah, you might need to learn deep learning properly. Okay. Yeah, if you've started doing the deep learning course, deep learning.ai course, you will get a good knowledge. But personally, I found that course very theoretical. So after I was done with it, yeah, I was able to understand stuff, but I wasn't able to code it, and I feel like that's a drawback of that course. Um, so maybe do something like the fast AI course, which I really liked. It's more focused on code. I'll put up all the links. So many links, but I'll put up the links. Okay. Uh, if you if it's necessary to implement everything from scratch, that actually depends. I mean, depends on what your objective is if you feel like you don't want to learn the algorithms, you just want to make stuff, then maybe no, not required. But if you want to, say, write papers in the future, or maybe implement your own algorithms, or modify existing ones, then you should sort of know how to do it from scratch, even if you don't do all of them from scratch. At max, just try to have an intuition of all this stuff, so then you can understand it. Good Python courses. Actually, I'm not sure about courses specifically for Python, but I guess Udemy has a few good ones. I've never actually done any course on Python, so I won't be able to give you a personal recommendation. But you don't just pick up any random course on Python, and I feel like that's enough for a start. And then later, when you're doing projects, you can learn as you go. Okay, should you spend your summer on DSA or MLDL? Okay, that again depends on what you want to do. If you want to go for placements, then focusing on MLNDL is probably not a very great idea fully. You can learn it as a side, but um, if not, then it's cool. If you are not going to sit for placements and you want to probably go for higher studies, then you can work more on MLDL. But again, I would suggest that you do DSA properly. It's a extremely important course, and throughout you will need it. Even for machine learning, after a point, you will need it. So this thing itself is a data structure, and there's no way you would know all of this if you don't do DSA properly. So that's it. Okay. You will honestly never be done with theoretical, but I mean, it's a continuous thing. People keep making new networks, new projects, and there's not an end to it. But um, I would suggest that you start coding as soon as you can. Yeah, you first pick up stuff from the net. So, for example, this code is something, this code is something which I did pick up from the net. So this is part of the official PyTorch repository itself. I mean, some of this part. So the Inception modules are something which were defined by someone else in the paper itself. But what I did is I took that and then I tried to modify it for my use case. So the way I would suggest, and I find it easier to learn, is that you pick up codes which are already there and then you try to modify them to fit your case. So you take something, use it in the way they have, and then try to use it for something else. And most importantly, try to understand what they have done. And I feel like if you do that for a few projects in time, you will learn a lot more than if you just sit and try to do courses or just look at papers. So, I mean, to continue on this, I was trying to do this myself. So this is one repository I had made for papers. So I took some of the most popular papers of the past few years and I've tried to implement them. So all of these are the papers which you might find on the Papers with Code website. And then I've tried to implement it on my own. I guess it's just an easier and better way to learn. Um, yeah, about reducing the amount of data, yeah, actually there has been uses. There have been a lot of research on this. So if you take something like the reason of why it takes so much data is because the fundamental way which we are doing convolutions is not accurate to learning, right? So something like Inception or something like if you take the newer ones like MobileNet and all that, they have tried to reduce the data requirements. Again, if you see transfer learning, that was the whole point. So you take something which you have already trained a model on, and then so for example, after I take this ResNet 18, which I had shown you initially, ResNet 18 or 152, whatever. If I take this, I can literally give it just 20 pictures of each class, of each type of disease or whatever, and it would still give me around, I hope, around 85% accuracy, which is really cool. Cool. Thank you guys for attending. I hope you learned a lot. And for those of you who are starting off, I hope you didn't freak out because that was a lot of information. Yeah, if you have any questions, again, just drop me an email. I will send you all the links to it. So don't worry about that. You're welcome. It's awesome. And it feels really cool that you enjoy. Chalo, thank you guys as well. Thank you for staying. It's been over an hour. Wow, it's been over an hour. Okay. Yeah, if you have any further questions which you maybe think of later, just drop me an email. Okay. Thank you guys. Have a nice day and stay at home and keep learning because you will not get this time back. Thank you.